support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama-BUENA Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We're here today at Stine Elementary School, home of the Vikings, for the Science for Kern Challenge. And we're here today to do the math in 3, 2, 1,
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Marylou.
And in studio we have with us Gavin. And Gavin, if somebody wanted to get a hold of us to Do the Math, how would they do that?
Well, you can go for math homework. Help call 636-4357, toll free 1-866-636-6284. And for their email, dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
Can people get a hold of you that many ways?
Not exactly.
Not exactly. Probably just a phone call or an email probably, right? Things like that?
Yeah.
Why don't you let everybody know where you go to school and what grade you're in?
Well, where I come from, I go to Downtown Elementary School, home of the Dragons. And what grade I'm in 4th grade.
How's 4th grade going?
It's going pretty good.
Yeah. What's the best thing about 4th grade so far?
It's pretty much like, I like math most of the time.
So you like math most of the time?
Yeah.
Good. Do you have any idea why you're here?
Well, you guys invited me here to do some math.
Right. So if you like math and you're going to do math, what do you say you do some math? You ready?
Yeah.
All right. Over to the board, young man.
Come on, kiddo.
All right.
Which
Now,
finger?
it's my understanding that you are pretty comfortable multiplying numbers.
Yeah.
All right. So, Marylou, how about if we put up there 54, so we'll use a 5, one of your favorite numbers, I understand,
Yeah.
times, and Gavin, what other two numbers would you like to put up there? A two-digit number, any number you like.
I like 32.
All right, 32.
There we go. All right, Gavin, can you lead me through this, how you would solve this problem?
I would solve it using like an area model.
Oh, my favorite way to solve. Can you kind of explain what an area model is for those who don't know what that is?
So an area model is something that you can do it as an easy way by separating one of the numbers and doing it the same way with the other number.
So what you're really doing is you're just pulling it out as place value, correct?
Exactly.
Okay, because the 5 is in the tens and the 3 is in the tens, right?
Yeah.
So you just expanded it, right? Decomposed the number and you did 30 plus 2.
Yeah.
Right? And here for 54, you did 50 plus 4. So we have our tens and we have our ones. So do we need to break this box up a little bit more?
Yeah.
So you're making it into 4 quadrants, right?
Yep.
Okay. And what are you going to do first?
So we have to multiply the numbers. So everyone knows 4 times 2 is 8. And 4 times 3, so we have to put the 0 over here. And 4 times 3 is 12, so we have 120 in total.
So it's really 4 times 30, but you took that 0 out to just kind of go 4 times 3 to get there, correct?
Yep.
Okay.
And for 2 times 50, we put it over here, and we put the 5 times 2 is 10, and we make it as 100.
Okay. Keep going.
And as we know, 5 times 3 is 15. So if we want to combine that, put the 2 zeros up here, 5 times 3 is 15. So we have a total of 1,500.
Okay, so now what do? You have these 4 numbers. What's your next step?
So as we do, we have to put the greatest number. So we put 1,500 over here, put 120 over here, 100 right here, and 8 right here.
And what are you going to do with all 4 of these numbers?
Add them.
Okay.
So we put a line down here,
Yeah,
makes an 8. There we go. And we keep them going till it makes the equal number.
Okay.
So
You have 5 plus 1 plus 1 is, okay.
and we don't put the final one if there's a 1. And we make a total of 1,728.
Very good. Can I show you another way real quick?
Yep.
Okay. This area model is perfect. I love it because it shows place value, right?
Yeah.
So as you get older, you're going to find another strategy, which is called the standard algorithm to this, okay? And this works, it's the same method as this. But we're going to be taking away all these zeros is what we're going to be doing. So I'm going to start like you did with multiplying 4 times 2, my 1s, right? Which is 8.
Yeah.
And then I'm going to go to 2 times 5, which is really the 2 times 50, right?
Yeah.
But we know 2 times 5 is 10 to get me 108.
Wow.
Okay. Then we're going to bring our 0 down here. Now we're going to go here to 3 times 4, right? I put a 0 because that represents my 1s because we're starting with our 10s.
Oh.
So what's 3 times 4?
3 times 4 is 12.
Okay. And then we have our 5 times 3, which is what?
5 times 3 is 15.
Carry plus 1
16.
is 16. Okay. We're going to add these together and let's see if we get the same answer. Did we get the same answer?
We have the exact same answer.
We do. This strategy only works, it's a shortcut. It only works because of this, okay?
Wow.
And there you go.
There you go. That's 2 different ways to multiply those numbers, and we've got a bunch of other ways for you to learn how to do it also. But first, let's take a look at today's Math in the News. All right, today's Math in the News has to do with a puzzle that I found in the newspaper. Have you ever heard of KERN?
No.
All right, well, you're going to learn about it today. And if you take a look at some different games and puzzles, especially with math, you may find this game in there. This is actually one of the games that students can participate in if they happen to have their school entered in the Math Field Day event that is coming up at the end of this year. So this is actually one of the events that you could partake in, and you might be the grand champion of the county. So here's how it works. So it says the logic puzzle that makes you smarter. And you can use the numbers 1 through 6. The numbers 1 through 6 must all go up on top. So every row must have the numbers 1 through 6. None of them used more than once.
Okay.
Every column must have the numbers 1 through 6. None of them used more than once. So when we take a look, we can see that up in the corner it says 11, and then there's a plus sign. Do you have any idea what that might mean?
That means we have to add the 11.
So we have to add numbers to get to 11. All right, so let's take a look here. So if we know that we have to add, and we know that these two are blocked off with that dark line, all right? So we have to add 2 numbers that are going to add up to 11.
Okay.
But we can only use 1, 2, 3, 4, 5, and 6. So which 2 numbers must we use?
We should definitely use the 6.
Okay.
And we should use like one of the even numbers.
Well, if we use 6, what else do we have to use? So let's say I put the 6 right here. Okay. What other number do I have to use to get to 11?
5.
5. I have to use that. Okay. So you see how that works?
Yeah.
All right. So that's kind of how you can start. And when you take a look, you can see here we have 2 numbers, and they have to divide to get to 2. So what 2 numbers can you think of that will divide to get to 2? Now remember, you can only use 1, 2, 3, 4, 5, 6.
If we use,
So think of even numbers, right?
we can use 4.
4 divided by what will give us 2?
4 divided by 2.
Right, so we could use 4 and 2, right? Could we use 2 and 1?
No.
What's 2 divided by 1?
2 divided by 1 is 1.
It's 2. Anything divided by 1 is going to be itself.
Oh.
Okay. What about 6 divided by 3?
6 divided by 3 is 6.
6 divided by 1 is 6, right?
Yeah.
If we have 6 and we divide them into groups of 3, how many groups of 3 will we have?
We will have 2
Right.
groups.
So we could use 6 and 3 and get 2, right? So that's kind of how we start the game, all right? And we can see, I went on to the next step, and let's put your 6 and 5 up here. We did that. If there's a number all by itself in a box, and there's no operation symbol for it, such as the 3, we know that the 3 must go there. Here's another 11 with 2 of them. We know it's 5 and 6. 11's always going to be 5 and 6,
Yeah.
right? We have a 2 by itself, we have a 3 there by itself, and we have the 1 by itself. So what I did is I put those in because we already know what those are going to have to be,
Yeah.
okay? So then what we can do is we can take a look and we see that we've got that, and we're going to see that we need to get a 5, okay? And we have to subtract 2 numbers to get 5.
Okay.
So what 2 numbers can we subtract that will make 5?
If we subtract,
And we can only use 1, 2, 3, 4, 5, 6.
so we subtract to get the 5. So if we try to subtract,
Because we have to start higher than 5, right? Because we want to end at 5.
what if we try to subtract it like 10 minus 5?
We could, but we can't use 10.
Yeah.
What's the highest number we can use?
6.
6. So what do you think we're going to have to start with?
6.
There we go. So we know we're going to have to use 6. And what am I going to subtract to get to 5?
1.
1. So that's an easy one, right?
Yeah.
So I look and I go, all right, now here's the 2 spots I can put a 6 and a 1. Can I put the 6 here?
Yeah.
Or can I put it there?
We can put it right there.
I could put it here, right?
Yeah.
Which one would be the better one? Because remember, I can only use every number once, horizontally and vertically. So would the 6 go better here or here?
There.
Second one?
Yeah.
Okay, so 6 and 1, right? That way, because otherwise I would have 2 6s in this column.
Yeah.
And we can't have that, can we?
Yeah.
All right, so that's just a little bit on how to start the game of Ken. And it's one of the, when you get into 6th grade,
Okay.
and when you're in 6th, 7th, and 8th grade, if your school participates in Math Field Day run by the Kern County Superintendent of Schools,
Yeah.
this is one of those games that you could play, and you've already got an idea how to do it, right?
Yeah.
All right, that's not a bad game, was it?
Yeah.
You like playing games?
I do like playing games.
Excellent, you're here on the right day. So come around here, young man. We've even got music for our little game board today, our Do the Math Plinko game board. So you have seen one of these before.
Yeah, I do.
And what was the name of it at your school you guys have?
We have one called the Drag and Drop.
The Drag and Drop. And what do you guys do? Like, do you do certain things with that?
So what we do about the Drag and Drop is one of our classes from each grade wins at right when one of our staff says what class wins.
Okay.
And there are several like chooses that what this can land on. Like one of them is fruit pop party.
Oh, so
free
you guys
dress.
win stuff
Yeah.
wherever it drops on.
Yeah.
That's fun.
Have you guys won something before?
The last time, no, this is new to our school,
So it's new to your school.
yeah, but I never won it.
All right. Well, you know what? Maybe be a winner over a Drag and Drop sometime soon. So come on over here. So here's one of the tokens that you're going to use to drop down.
Okay.
Okay. Now, taking a look at these colors, I would like you to choose any color you want.
Red.
Red? Okay. So you get to have that red and that red.
Okay.
That's a good color to pick because there's 2 of them, right?
Yeah.
If you said yellow, there's only 1.
Yeah.
Where do you think you should drop this so that it lands on a red?
I can drop it right here.
All right, so go ahead and drop that and then come on back and let's watch it drop. Ooh, close. They buzzed you on that one. Do you remember where you dropped it?
I dropped it right here.
All right, you want to try another one?
Sure.
Now, do you have a different strategy or are you going to stay with where you were and see if it bounces a different way now?
But if we try strategy one way, maybe we can try to head it the exact same way it went for the third one.
All right, try it. All right, come on over, let's see. Oh, you went further away. How could that possibly happen?
I I just have no idea.
Okay. Well, you take a look. When it hits one of these pegs, it can go 2 different ways, can't it?
Yeah.
So you might think, all right, well, it starts over here. It might end up over here. But if it hits that first peg and starts coming over here, it could keep on going that way. You want to give it another shot?
Wait, I think I have a strategy.
You think you have a strategy? Let me get these ones out of there for you in case. All right, so let's see how it works.
If we just put it right here, if it turns right and then down to the left, down to the right, and just goes zigzag, it might land on the red.
If it goes zigzag every time, right?
Yeah.
Try it.
Zigzag, zigzag.
Oh, will it work?
Oh!
That elusive yellow that nobody ever gets, you got it right there. All right, try again. You can get either red, it doesn't matter. All right. We're gonna give it another shot. I'll get these ones out of there for you.
Can we try to move it?
Uh-oh. Oh, there you go. Nicely done. So, what did you do different? Anything?
We tried to pick a strategy, but most of them didn't work.
But it's just chance, isn't it?
Yeah.
It's just one of those things. And we'll
Yeah.
do a little bit more with probability, and we'll do even more with Gavin when we come back. But first, we have an opportunity to head on out to Stine Elementary and see what they're doing with Science for KERN.
Hey, thanks a lot, Mike. We're here at Stine Elementary School. Michelle Roy's here with Science for KERN. It's another one of those great Tuesdays to get some science built into the classroom, and we've got a lot of really eager students here. They've pumped up this challenge. They know what's coming, and they really just want to get to it. So let's explain for our viewers at home a little bit first about Science for KERN, and then what our kids are going to be doing today.
Yeah, great. Thank you, Devin. Science for KERN is a mobile lending library for 4th and 5th grade students all over Kern County. We have 10 units that teachers can check out. The units can be checked out at www.science4kern.
That's the number 4, everybody. She did this thing.
It's the number 4. The program comes with it's turnkey ready, everything that the teacher would need, including a teacher's manual, as well as demo lessons can be provided as well by a certificated teacher, and that's available upon request. And then the best part is we come and pick it up when the teachers are finished as well.
Well, if you're watching, you're going to get a great demo here, because what we have
Yeah.
today, and I got to kind of play victim to this a little early. I shouldn't, is that the wrong word to use, victim? You shot rockets at me, basically, as soon as I entered the room. We'll explain. But basically, what we're going to get to design today is things that fly.
Correct. So we're going to be aeronautical engineers today, and our challenge is super simple. A straw rocket is what we're going to be building today. A rocket, the straw air powered, that blow in the straw, shoot the rocket. We have a starting line there in the back of the room, and our objective today is to launch a rocket from the straw and hit the door. That's ultimately where our ultimate objective, our ultimate goal for the project today. But before we get into any fancy rocket building, we're going to build what I'd like to call a preliminary rocket. So each student's going to be getting a rectangular piece of pink paper. When you get your paper, students, you're going to be getting a piece of pink paper with a rectangle on it. Cut out the rectangle. And then, once the rectangle is cut out, I want you to roll the rectangle. So cut it out. And then roll the rectangle long ways around your pencil. Definitely a two-handed job. And you know, if you need to help one another in your teams, that might make this part of the job a little easier. Roll it around the straw, and then tape it.
Hi.
Right. Nicely done. Roll it the long way. Roll it up. tube. Right now, I just have a straw tube in my hands, just like all of yours. But if I blow, what happens this way? Yeah, the air just blows right on through, right? So what I need to have happen so that the air doesn't blow all the way through is, so check this out. Here's my tube. I need to just take one end and just pinch it over a little bit. So see how much I have folded over? Everyone see that all around the room there? About that much. And then take some tape and just tape it down. Because we're stopping the air from just traveling right on through our tube. Otherwise, our rocket won't work. So fold that tip over, tape it down. Excellent. Perfect. Tape that closed. And then, after you've got it taped, you can do what this student over here just did. Check it out. So he's got his rocket taped, and he took his straw tube, and he's got it on his straw ready to launch, but no launching yet. That's as far as we're going at this point.
We use the word stages when we talk about rockets. This is really just stage one of the construction process to make sure that we have our initial launch ready to go for the first step of the prototype. So we're going to take a break and send it back to the studio. When we come back, we'll see how much further we are along in the process to see how far this group here at Stine Elementary could fly. But for now, we're going to send it right back to you in the studio. Mike, take it away.
All right, thanks for that, Devin, and we'll check in with the kids at Science for KERN over at Stine Elementary this time. We do have phone tutors available until 5:30, as we do most Tuesdays and Wednesdays throughout the regular school year. In studio with us is Gavin, a 4th grade student from Downtown Elementary. And Gavin, is there anybody you would like to send out a special hello to real quick?
So I want to say a special hello to my teacher, Miss Robeson. She's a very kind teacher. And I want to say hello to any of my class who is watching right now. Some of them are really nice kids to me, some of them not quite, but I have really good friends.
Good. You know what? That's important to have a lot of good friends, right?
Yeah.
There you go. You know what? And there are millions of other kids watching you at the moment right now also.
Yeah.
Worldwide. You ready to do some more work?
Yeah, let's do some more work.
All right. Over to the board, young man. That's exactly why you're here. So I know that in 4th grade, you may have started a little bit with fractions.
Yeah.
Okay, so we're going to help you a little bit with common denominators, first of all.
Okay.
So we're going to take 2/7 and add 3/7. So Marylou's going to work with you, kind of figure out what you know right now and how you can solve that problem and move on with other fractions.
So what do we know from this?
So what do we know from this? That if you have 2 7s and I have 3 of them, so let's make this a relation to food. Like if you had
My favorite thing to do is food.
Yeah, so if you have like 2 out of 4, 2.
Let's think of one object. We have one object, right?
Yeah.
What food could this be?
This could be
Something we could break into pieces.
pizza.
Pizza, okay. So we have a rectangular pizza, okay?
Mm-hmm.
And we need to break it into
7.
7 pieces. Have we done that?
Yes.
Okay, so continue on. So we have our pizza, we have it in 7 pieces.
But we have to share it with anyone else who wants the pizza.
Well, there's only the 2 of us right now, okay? And this is what I ate. I ate 2 pieces.
Mm-hmm.
Shade in 2 pieces for me.
Okay, so I just
Okay.
go across.
That's fine. So there's mine, right?
Yeah.
I'm going to change the color here. Hit the green for me. Okay. Now you ate 3 pieces. Shade in 3 pieces.
Oh.
No.
Oh, I'm sorry.
Try that again. Try it again.
I'll
That's
just do
okay.
it like that.
let's do this. There we go.
Right, the other
Switch
pen. There
pens.
you go.
Yeah. I did no idea.
So did we eat the whole entire pizza?
No.
No. How much did we eat though?
We ate like 5 pieces.
We ate 5 pieces. Okay, the 5, is that going to be your numerator or your denominator?
So the 5 would be my numerator.
Okay, let's put 5 in there. So we ate 5 pieces. Out of how many total did we break it up again?
7.
7. So again, fractions, and we have the same denominator, okay?
Yeah.
And if you notice that we're keeping that same denominator all the way through the answer.
Yeah.
Are we adding this together? No.
No.
But are we adding our numerators?
Yes.
Yes, because our denominator is our whole, right?
Uh-huh.
It's out of 7, okay? That's why it stays continuous, because that's our whole, okay?
Okay.
So let's try one more problem.
Okay,
All right. So let's try 4/9, 4 over 9,
all right. I'm gonna write this. We have 4 over 9.
plus 3 over 9.
Okay, I'm going to ask you this time to draw a rectangle for us. And make it pretty big, okay? Can you break that into 9 pieces?
Sure.
I'm going to put one right here. Here we go. Let's do here, okay?
Okay.
That'll make it a little bit equal, right? Okay, so we have our 9 pieces.
Yeah.
I ate 4.
So
Here, I'm going to switch. Hit that. There you go. See if that works.
I think that's on you.
Yeah, it's on me. You got to hit it yourself. Okay, let's see if it works. That's okay. Let's leave green.
Okay, I'll just leave green. So you ate 4 pieces.
Right. And you ate how many?
I ate 3 of them.
Okay. Show me 3. Here. Switch pins.
Yeah, I forgot. Oh, it just stays red. 1, 2, 3.
So, how many total did we eat together?
We ate 7.
7 what?
We ate 7.
How many pieces did we break that up into?
9.
Show me as a fraction.
So, what I would do for example, I would do a circle.
Well, do we already have the answer?
Yeah.
Okay, can we just go ahead, can we show it in a fraction form?
Sure.
There you go. So what's our answer again?
7 and out of 9.
Perfect. Show me that as a fraction. Okay, I'm going to give him one more without a picture. Okay, you ready?
Sure.
Okay, so I have 1/6.
6.
1/6. Ready? Plus 3/6.
So.
Without a picture, do you think you could solve that?
Yeah, I could solve it.
Okay, tell me how you're going to solve that.
So I'm gonna solve it. There are 6 pieces. You ate 1 chocolate chip cookie, and I ate 3 more chocolate chip cookies.
Okay.
So let's put the equal sign down here. As our answer, it would be 4 out of 6 cookies.
There you go. Nicely done, and for doing some great work. Speaking about food, you've got yourself a meal courtesy of our friends at Grill and Burger, so congratulations on that. Hey, we do have phone tutors available until 5:30 this afternoon. We'll be back with more right after this. Today we're at Highland Elementary, home of the Hawks, and we're here to Well, today we're at Highland Elementary, home of the Hawks. We've got some 4th and 5th grade students, and we're going to talk a little bit about triangles and angles. All right, you guys ready? So first of all, before we even worry about what's on the paper, what do you know about triangles?
Most of them are acute angles.
Some have acute angles, right? What else?
They have 3 sides.
They have 3 sides, right? That's probably the easiest thing every kid knows about triangles, that it has 3 sides, right? So we know that it has 3 sides. That's what makes it a triangle. You made a comment that some of the angles are acute, right? Are there any other types of angles?
Obtuse.
Obtuse. And what else?
Right.
A right angle. So what's the difference between these? How do we know if it's acute, obtuse, or right?
If it's an acute, it's a very small angle.
Okay, if it's acute angle, it's a small angle. Now, how small does it have to be?
At least like this or like that.
Could it be like this?
No, that if it was like this,
What if it was like that?
that's a right angle.
Well, then, what about this? Because that's just a little bit different, isn't it? So what would that be? Almost right? So it would be an acute, right? Okay. How do we know, instead of just looking like, all right, we know that's a right angle, how do we know?
We know because it's 90 degrees or less.
Okay, so if it's a right angle, it has to be what?
90 degrees.
90 degrees. So if it's less than 90 degrees, then it's the acute angle, right? What about the other one you guys mentioned, obtuse? What's the deal with obtuse? You guys know what obtuse is? What's obtuse?
Bigger than 90 degrees.
Bigger than 90 degrees, right? So we know that the right angle is 90 degrees, acute is less than 90, and obtuse is bigger than 90, all right? And we know that triangles have 3 sides, all right? So let's take a look at the paper that we've got, all right? We've got a lot of different angles on there. So what I want you to do is, with your partner, work on these and see if you can classify them as either acute, obtuse, or right angles, all right? Go ahead. Who thinks they've got them 100% correct? You feeling pretty confident on that, huh? All right, let's find out. So let's start up on the top left, all right? What's that?
Obtuse.
How did you know that was obtuse?
Because it's bigger than 90.
It's bigger than 90 degrees, right? It's almost a straight, it's almost perfectly straight, isn't it?
Yeah.
Okay, so we know that that's going to be more than 90 degrees. What about the next one next to it?
That one is also obtuse.
That's also obtuse, right? What about down in the middle?
Obtuse.
Obtuse. What do you guys have for the middle on the right side?
Acute.
Acute, right? So that's the first one that's acute. So what did you notice about that? How did you know it was acute?
Because it's smaller than 90 degrees.
It's smaller than 90 degrees, right? Do we have any on the paper that is a 90-degree angle?
Yes.
Which one?
Bottom left.
The bottom left, right? That's the right angle. What is the little mark in there, right? Have you guys ever seen where they make an actual square sometimes on the angle, right? This one's a little curved, but you guys can tell that's the right angle, okay? And what about the last one? Altogether, what is it?
Acute. Acute.
Acute. Very nice, all right? So there we go, classifying some angles with our work towards triangles coming up with the 4th and 5th grade students at Highland Elementary. And once again, thank you to the staff and students at Highland Elementary School. We always have a great time when we're able to go out and do a little bit of math in your class at different elementary schools. And speaking of math, we also do a little bit of science at elementary schools. We're going to head back out to Stine Elementary and check it out.
Thanks a lot, Mike. Back here at Stine Elementary School with Michelle from Science for KERN and our fantastic students who are in the midst of our prototyping phase for our rockets. We have passed the initial design phase. We're going to test out our very rudimentary prototypes here to see how far along in the process we are with what we've already built.
Right, come on over, ladies. So let's see, toes on the line. And let's see, hold your rockets up for the camera. Hold them out there so that he can get a good look at them. And let's see, are you ready? Let's launch and see how far they go.
You're gonna look out to, oh!
Oh, yeah, all right, so go pick them up. And you can take them back to your seat.
Do us a favor, where were each of you on those
Yeah.
shots? Show us where they landed here from the
Stand in
line.
your landing spot.
Okay, so a couple of interesting things here. Even though the designs looked very similar, the flight paths were very different. Yours started off kind of over here on this side, right? And it kind of flew low and curved and then kind of landed right here. Yours went on a much more wild path. It started off over here, went up a little bit, curved, and then buckled in sharp to the right and landed in one of these cubbies down low, right? So who knows if this wasn't here, that could have gone even farther that way. So even though your designs were very similar, they both took very different paths. Why do you think they flew differently?
Because I taped it
So-
and I blew it hard.
So there's two factors you mentioned: the tape that you used and how hard you launched it from the straw. So let's compare what we can look at, right? We can at least look at how yours are taped together and see if that has an impact. Do you feel like yours has more or less tape than hers?
Less.
So I wonder if having less tape might influence the path of the rocket as you design them further. All of these things have an impact when we compare designs, right?
Yeah. So do you think more tape makes the rocket heavier or lighter?
Lighter. Or no, heavier. Here we go.
Okay. So you think yours is heavier than hers? Yours is lighter and it went farther, right? Huh. Interesting. Good observations.
So if you return to your desks and continue to work on your designs, how might you change your designs to get a more desired result?
I would try to put a bunch of tape on it.
You would put more tape on it so you don't want it to fly. Well, do you feel like that would help it fly straighter, perhaps? Or do you think there's something else that might influence the direction of the flight?
Straighter.
Okay. How about you? What would you do?
I'll put less tape on it.
You're interested in a design that involves less tape so you can fly farther. So if there's a way for you to remember or mark where you landed this first test, and then when you come back for your second design, we'll see if it actually does
Remember
change
where
that.
you are.
Okay? We have 3 other designs right here at the starting line that are eager to launch
All right,
off here.
gentlemen, let the ladies move out of the way. Are you ready? You ready? I'm going to count down. In 5, 4, 3, 2, 1. Here's what the fun.
So,
So go stand by your rocket.
what were some of the observations of what you noticed
Pick up your
regarding the
rocket.
launches and the flights of your devices?
So
What did you notice happening during the flights? Did you see them flying in a straight line?
No.
What happened?
When I blew into it, the thing went far, like a little more far than Jerron's, and started curving.
So, if you ever see baseball, sometimes you'll see a ball in slow motion that kind of wobbles like this before it drops. That's called knuckling. And it looked like a lot of your designs knuckled. What do you think was the cause of that as it flew forward and then slowed down?
Like the way how I put the tape, like it's just sticking. Also, I think it's just gonna
So, when you go back and redesign this, what do you think is a change that you'll make in your design?
like try to make this tape stay down.
Okay, and that you think will help with some of the aerodynamics that'll allow it to fly and cut through the air in front of it more easily. Okay, one other thing I noticed that may have had an impact too is when you got set to launch, some of your straws were kind of parallel to the ground and pointed up, and I think one person had theirs tilted a little bit down. Do you think that could have an impact on the distance that it flies?
Yes.
Why do you
Because
think that might have an
sometimes when, like my dad tells me when I'm playing football, if you throw a football high, it's just gonna go down and not that far. When you throw it like low and like directly at something, it's gonna like go where you want it.
So something you want to be more mindful of on the launch then, from what I'm hearing you say, is the angle at which you launch it. So that's something to keep in mind for the next test around. All right, so go ahead and redesign yours. We'll do ahead and check out another
All right, so
round
we're
of
ready
testers
for
here.
another launch over here, Devin. Ready, ladies, in 5, 4, 3, 2, 1.
Yeah. Yeah.
Go stand by your rocket.
Now, one big difference I noticed in the launches was how far up the straw your rockets were. Yours were all the way on, as much as they could be, and I noticed you kind of put yours a little bit towards the end before you blew. What was your thinking when you did that?
I'm not sure.
Okay. Why do you think that might have had an impact on where yours landed compared to where theirs landed?
Because I think I had mine lowered down.
So, when you launch again or redesign, when you prepare for launch, what's something you want to keep in mind to see if that has an impact on whether your rocket flies farther?
Make sure it's on right and you have an angle of perspective where you're trying to launch it.
Okay, so keep that in mind that that might have an impact. And is there a way to redesign your rocket so that it does stay all the way on the straw more easily? Or perhaps we need to change something about the straw too. Just some ideas to throw out there. Go ahead and head back to your redesign. We've got another group of 4 that are set to launch here.
Ready? Ready to launch in 5, 4, 3, 2, 1. Oh, yeah. No, okay, go stand by your rockets.
Who's with the farthest?
So what'd you learn?
Put less tape.
Less tape. Now, when we were waiting over on the starting line, we were doing a little bit of preliminary testing. And explain a little bit about what was going on when you were trying to blow on a small test.
I pushed it too hard and it wouldn't go up
Okay, and so why do you think it wasn't going?
because I pushed it too far and then it wouldn't come out.
Oh, okay, so it was actually
tighter.
like literally stuck. So these, what do you think made these two just go just a little bit farther? Because, I mean, honestly, you guys are quite closely clustered together. They didn't really have that much more success than the two of you. So what do you think was a little bit of a difference in their design versus your design?
I think that mine went farther because I blew harder.
Okay. So you think the amount of air that you blow makes a difference? All right. So what do you think?
I kind of made mine blue so it'd be easier to come off
Okay.
of the straw.
How hard do you think you blew?
Like a normal, but not too hard or not too soft.
All right. All right, so you guys can go back to your seat, and Miss Jamie's going to have some directions for you. All right, one more launch. You ready?
We got one more round of launches. We'll see how this
5,
flies.
4, 3, 2, 1. All right, go stand by those, and let's see. Oh, wow. Interesting.
So, even though the direction was a little varied, the distance seemed to be almost even across the board. The same line on the tiles.
Interesting. You all ended up in the same spot. Look at your designs.
Both like 1 inch
Look what your classmates did. Are they that similar? What do you think?
Not really. Not to me. I think I added too much tape.
That's awful tapey, isn't it?
It's so
But
sticky.
look where you're standing compared to your classmates.
It's like 1 inch.
It looks like you just a little bit. All right, you guys can go back to your seat and start working on your second iteration of the rockets.
And it looks like the second iteration is going to have a pretty significant addition on top of it that we'll take a look at when we come back to our next break, and we'll see what impact that has.
Right, exactly.
So we're going to send it right back to the studio, and when we come back, we'll have our final test of the afternoon. Let's get some tailwind action with some of our fuselages here. Right now, send it back to the studio, Mike. Take it
All right,
away.
thanks for that, Michelle and Devin. We do have phone tutors available until 5:30. More importantly, though, we have Gavin, a 4th grade student from downtown Elementary, in studio with us this afternoon. Sent out a big hello to all of his classmates and teachers. That's very nice to do.
Thank you.
But you are here to do work, so back to the board, young man. Here we go.
Yeah.
You've multiplied, you showed us the area model, and you did very well at that. We
Yeah.
introduced you a little bit of like denominators with fractions, and you kind of caught on to that pretty quick.
Yeah.
Now you need to show us your mastery of subtracting large numbers.
Okay.
Here we go. Mary Lou, if you write down the number first.
Okay.
142,075.
142,000. Oh my goodness.
142.
That's what I know.
75. Whoa.
Wait.
Yeah, I want that zero in there for him.
Okay, 142,000.
1,075.
Yes.
Minus
Oh, it's a minus 12.
29,428.
Okay.
So Gavin, if you would please solve that problem and explain it as you go along.
Okay.
There you go.
So, as we can see here, 5 cannot subtract with 8. So what I would do, go next door, and we would borrow 1 from 8. That's how we can make it 6, and we can make it as a 15. So when 15 minus 8, we can make it as a 7. So when we're over here, it can go 3, 4, and then it just has to repeat itself over.
Why are you changing the 2? It's correct, but why
I know,
are you
but
changing?
because there's nothing in here, because it can't subtract with 4.
So you need to regroup, right? Rename over?
Yeah.
What are we going to change the 0 to?
A 10.
Okay.
And after we change it to a 10, it will turn into a 6. But here's the problem with this one. If 1 minus 9, take it, then it'll be a negative 8. So we have to head back over here, borrow a number from the 4 to make it a 3. And after we make it as a 3, we can make this an 11. And then after that, there'll be 2 numbers left in that. 3 minus 2, everyone knows it's 1. And 1 minus nothing is 1.
There you go, nicely done, 112,647, well done. And for your great effort today, you've got yourself a couple of tickets courtesy of our friends at CSUB Athletics. Any sporting event you'd like to go to, you're more than welcome to head on out. All right, we're gonna head on out one more time and see how they ended up with this science.
Well, thanks a lot, Mike. We're back here at Stine Elementary School. Science for KERN. Michelle Roy's here. We are at our final testing stages for our rockets. They were able to build the prototypes and have now added a very significant component, and we're going to see how that changes the results.
Yeah, we've been messing around with adding fins to our rocket. And we've had a little bit of preliminary testing here in the classroom, but I think it's time for the real test.
So, theoretically, what is the addition of a fin designed to do on a streamlined kind of rudimentary rocket like they've designed already?
It has something to do with keeping it straight.
We mentioned there were some issues with students kind of knuckling their rockets as they reached a certain point in their flights.
Correct.
So we'll see if that has an
Let's
impact.
see if there's a difference in direction, maybe. And I'm thinking out loud, maybe direction keeps it straighter. Maybe we'll get some longer distance with straighter rockets.
It's time
We've
to
also been talking some about blowing and the power of the breath, too. So
that initial
we'll see,
launch propulsion
correct.
plus
We'll
lung
see-
capacity.
Correct. We'll see
Well,
what happens with
let's
that, too.
put theory into practice.
So where's my first team that's going to be testing? I had some pre-picked. I had a team picked first. Here. And all right, so are you ready? And launch in 5, 4, 3, 2, 1. All right, let's go with your rockets. And so did we go further this time?
Hold up your rocket so that we can get those on camera. Turn around, sweetheart. So what do you think made the difference this time?
Putting my things to it.
What are these called?
Wings.
Wings, fins, right? And so hold yours up for the camera so we get a good look at it. And yours too for comparison's sake here. And so why do you think yours went further?
Because of these. And I made less tape.
Less tape. So what do you think less tape resulted in less what?
Weight.
Less weight on the rocket. So do you think there's something to be said maybe for a lighter rocket maybe goes further?
Yes.
So it's going to be interesting to see what your classmates say when they test their rockets too. All right, well done. Well done. All right, let's go test with another group.
Let's get our second group lined up.
3 more on the line. Actually, let's get 4 more of you on the line. Shift this way. Get you squeeze in there too. Already, let me get out of the way. In 5, 4, 3, 2, 1. Oh wow! Check that out. Where's yours? Did it not come off? Oh no! So come stand by me too. Check this out.
Well, that was fun.
Was yours? Did you just try to test? All right, next 4 ready? Okay, go ask Miss Jamie and she'll help you put yours together. So, where's our farthest launch?
Right over here.
All right, so tell us a little bit about your rocket. Did you go further this time than your first test? How come?
I used lightweight paper and added these things for velocity and speed.
So how do you think these, what do we call them? Fins? Okay, and so how do you think they maybe make a difference?
Because they're aerodynamic.
Ah, what do you think makes them aerodynamic?
The way they're shaped.
I'll also kind of note the fact that instead of them kind of being bent out and crossed, these sets of wings seem to be kind of parallel to each other. So I wonder if that makes it easier for the wind to cut through between them and provide a little bit more lift along the way too.
That's awesome. Well done. So how about you over here? Did you go further this time than the first test?
Well, no, but I added I don't know what these called.
Pointy? You got a pointy tip there.
Yeah,
But closed up still.
Yeah.
Okay.
I got this one went farther because I didn't add these, and when I was like at the corner, it went right here because like it had to go right there, but it went right here because they had these.
Wow, interesting. Well done. All right. Ready to launch? One more person up on the line. Ready to launch? In 5, 4, 3, 2, 1. All right. So on this test, oh wow. So did you go further this time than the original test? Why do you think so?
Because the wings were like curved up, and the tape was still like that from last time.
You taped your tip? Okay, so hold yours out. Hold it out with your finger. Compared to this, can you tell us about your most original design there?
I just cut out art to design it, and I put a bunch of tape.
So did these heart-shaped fins make your rocket go further this time than you did on your first test? Ah, so further, not as far. How about you? Did your rocket go further? Hold it up so we can see your fin design.
It got much further because last time I got it right there, and since I added much more tape and I blew harder, it got much.
Oh, and you blew harder too. Okay, so maybe that has something to do with it too. Check out this one. So her rocket didn't go quite as far as everyone else's. But look at the fin design. Right, come back over here and hold yours up compared. So do you think we must be getting at something with this sort of fin design versus the heart-shaped fins?
Mine's on one side, on different separate sides, and hers are just on one.
Yeah, interesting. Well done, everyone. You can go back to your seats. All right, I need 4 more people on the starting line.
Next floor, line up.
How? Perfect. All right, ready and launch in 5, 4, 3, 2, 1.
Duck
Go stand by your rocket.
Okay, so we're gonna need to see that in slow motion eventually. We have our first headshot of the afternoon, ladies and gentlemen. Sir, we need to talk. First of all, my lawyer will be in contact with you shortly. Secondly, talk a little bit about this flight compared to the first flight.
So on the first flight, it didn't go as far,
I could tell.
but so I added, what they're called. So I added,
So kind of like what birds would have, maybe wings, flaps, or even like a fish. These would be called fins, right?
Yeah.
Okay.
and I added like a little too much.
I don't think you did. I don't think you did. If the whole point is to see it fly farther and higher, it certainly achieved that goal. Now, something I noticed here is that the nose of your rocket seems to be pinched together instead of folded over. Is that something you kind of had in mind when you designed this? So what was your thinking when you did this?
So I was thinking that if I did that, it would go further on the first try, but it didn't. So I just like squished it more, and then it went further on the second try.
Well, it was wonderful. It was a great effort. I'm fine. Thanks for asking, by the way. Here you go, sir.
So another really interesting fin design. Hold that up. And this and yours on this launch, what place did yours get? It barely went.
And I'm sad.
Yes, but look at the fin. Look at the fin design there. So why do you think this design didn't go as far?
Because I think I added way too much paper.
Okay, too much paper. All right, and the
I thought it would make a pretty good balance on it.
similar fin design to what we've already had. How about over there too? Oh, tell us about that.
I put 2 fins and then taped them.
All right. So we have, you guys can return to your seats. Thank you. We have one more group to test. Launching in 5, 4, 3, 2, 1.
To the door. Wait, we got one more coming.
One more.
Okay.
Wow. So we've already heard from those two, and that was actually their 3rd try. So they've modified even again, but this is our 1st try. 2nd try, right? Tell us about yours. Oh, check that out. Can we have you two come over here and join? And compare yours to her fin design. And let's have a quick discussion around why these two went so much further than that one. What are you thinking?
I think it has too much tape. Yeah, I would think that it looks good. I would think it's just too much tape, probably.
And I think something I noticed is that you did something with the nose here. Could you kind of describe what you did with the nose of the rocket
Did
here?
you just launch this one and it almost hit the door?
No, I did this one.
This one almost hit the door.
That's interesting.
All right, 2 fins then, right? Huh.
Yeah, just one.
But
yeah.
what I did, the
What's that?
other ones were like this, but what I did, I curved them up just a little bit.
All right, interesting. All right.
So-
Well, thank you, ladies. Well done.
A lot of really interesting designs coming into play here at Stine Elementary. Michelle, if teachers wanted to take advantage of Science for KERN, how could they reach out to you and where would you direct them?
www.science4
Like the horseman.
kern.org.
Hey, a wonderful juxtaposition of design thinking and engineering and aerodynamics. Thank you so much for the opportunity. And thank you to everybody here at
We had a
Stine
lot of
Elementary
fun.
School. For the final time today, we're going to send it right back to the studio. Mike, take it away.
All right, thanks for that, Devin, and all of the students at Stine Elementary. Thank you also to Gavin coming in, a 4th grade student from downtown Elementary. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, EDISON International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama-BUENA Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.